All right, last bit for section 6. Um, if you're groaning, section 7 is a short one, but section 6 and section 5 are big. Rationalizing the denominator. For some reason, mathematicians don't like to have a square root in the denominator. There are some reasonable explanations for that, but it's more or less like putting your pinky out when you drink, or don't put your elbows on the table. It's just not proper. So looking at this problem here, we've got the square root of 7/8. And what you're going to be asked to do is rationalize this a little bit. So the square root of 7/8, because it's a fraction, we have a property that says that we can split that fraction up into just the square root of 7 over the square root of 8. So we covered that in an earlier slide. We can split that fraction up. Now we have a radical in the denominator. That's a no-no. So this is what we're going to do, and I'm going to go through this slowly, step by step, and I'm not going to use the document camera. We're going to multiply times 1. Because if you multiply times 1, nothing happens. We don't change anything. It's still the same problem. It's still the same number. Nothing. We haven't changed the original expression. I'm just going to pick a very special 1. What I'm going to do is I'm going to multiply by the square root of 8 over the square root of 8. And I got that number from whatever this denominator is. So the denominator was the square root of 8. I'm going to multiply by the square root of 8. But because I need to multiply by 1, it's the square root of 8 over the square root of 8. So that's where that square root of 8 came from. And that, again, the reason we can do that is because you're just multiplying times 1. Now let's multiply this through. For the denominator, the square root of 8 times the square root of 8 is just 8. So that works out really well. The square root of 7 times the square root of 8 is going to be, well, we can multiply those together and get the square root of 56. Not 54 like I did earlier, but 56. And it looks like I did some rationalizing before I got to the square root of 56. The square root of 8, if you did your factor tree, the square root of 8 is the same as 2 times 2 times 2. So that can be rationalized to 2 root 2. Once you have that, you can take that a step further. And we can simplify this a little bit. 7 times 2 is 14. We're not going to be able to rationalize that any further. And this 2 and 8 here, the 2 divided by 8, this coefficient divided by 8, we can reduce that. So you can't see it when I put like a finger over something, but if you ignore the square root for a minute, you just look at the 2 over 8, that's like a fraction, 2/8, which reduces to 1/4. So the final answer for this would be the square root of 14 over 4. Now, I put a whole bunch of things into that one slide. Going back to the beginning, we can split up a fraction into a square root over a square root. Because we don't like to have square roots in the denominator, we can multiply by whatever that square root is, divided by itself, square root of 8 over square root of 8. That gives us a denominator of 8. Square root of 8 times the square root of 8 is 8. And that's the whole point. That's the purpose of it. The square root of 7 times the square root of 8, you could either write it as the square root of 56 and then do a factor tree from there, and you'd get 2 root 14. Or you can rationalize the square root of 8 into 2 root 2 and go at it from there. You will have to then reduce this 2/8. 2 divided by 8 can give us 1/4, and that's where we get that answer. If you think you got that, oh no, I apologize. I'm gonna go through one more here, and then I'll give you one to try on your own. Rationalizing the slightly more complicated denominator, because that last one was way too easy. Now we have in the denominator the square root of 7 plus 2. So not just the square root of 7, but the square root of 7 plus 2. The way we're going to do this is we're going to multiply by 1 again, because it doesn't change the original expression. But we're going to multiply by a very special one. We're going to multiply by what's called the conjugate. And I've said that word in the past. when I've talked about difference of perfect squares. The conjugate is going to be the same thing, except instead of plus 2, minus. And we're always going to multiply by the, excuse me, by the conjugate. And the conjugate is always going to be whatever this expression is, except instead of plus minus, or instead of minus plus. The reason we do that is because this then becomes a difference of perfect squares, the denominator. If you expand this out, if you FOIL it out, what you're going to get is 7 minus 4. The first part of that expression squared, square root of 7 times the square root of 7 is 7. And the last one, 2 times 2 is 4. And it's a difference. So this is a difference of perfect squares. Square root of 7 plus 2, square root of 7 minus 2, which gives us a denominator of 3. We've taken that denominator of square root of 7 plus 2 and we've rationalized it. We've turned it into a rational number of 3. Now let's deal with the numerator. There's no expanding here, there's no foiling. We do have to distribute. And so this is 12 times the square root of 7 minus 2. We can distribute through the parentheses and get 12 root 7 minus 24. What we then, so we've done it. We've rationalized the denominator. The only thing we have left to do is to see if we can simplify it at all. Remember in the last example, it was 2 over 8. We have the same type of thing here. We've got a 12 over 3 and a 24 over 3. What we're really looking for is there a common, or is there a factor in this numerator that we can factor out? We can factor out a 12, which again, I know it kind of feels like we just went right back here again. But we can factor that 12 out, which allows us to divide. 12 divided by 3 is just 4. These are complicated. It says it right here, complicated. And I don't argue that in any way. I don't know if there's a perfect way to explain it quickly. And so this is an example, a step-by-step example. I'm going to put one more up. I'd like you to try it on your own. Please do try it on your own without just skipping straight to the explanation. If you get stuck right away, go watch the extra video on how to do it. If you get it, but you're not sure if you got it right, I'm going to put the answer up. And if you didn't get the right answer and you're not sure why, watch the extra video. So here's the problem. Pause it. Try this problem on your own. Look at the example that's right above it. Try and follow those steps. If you're stuck or if you don't get the right answer, there's a linked video. Try that or watch that. I'm assuming you tried it. I'm assuming you paused it and worked this through. This is the final answer. If you did not get that answer, watch the follow-up video because there are a lot of steps and it's not necessarily an easy problem. And so please do look at the follow-up video. If you got it, great. Move on to section 7.